Okay, so now we're going to talk about types of chemical reactions. And there's a lot of information in this section, but there's no calculations, so it's going to go a little bit faster, I think, than when we have calculations. So we're going to introduce you to types of chemical reactions. An example that you're familiar with probably is a combustion reaction, right? Where wax combines with oxygen in air to form carbon dioxide, right? That's called a combustion reaction, right? That's an example of it. And the reactions that we're going to consider in this section are combination, decomposition, single replacement, double replacement, and combustion reactions, okay? So let's look at each of these individually. So these are the ones I read in the previous slide: combination, decomposition. Let me give you a really blazing fast description of these. A combination is where you have two different things come together to make a compound, right? A decomposition is the opposite, where you have CD breaks apart. That's called decomposition. Single replacement is when you have somebody without a partner, BC, switching AC plus B, right? Switching partners. Double displacement is when you have two couples dancing on a dance floor and they switch partners, right? And then a combustion reaction is when you've got something A plus O2 combines with oxygen gas to make AO2. All right. So that's a blazing fast description of it. Let's look at these in more detail. A combination reaction, as I said before, is when you have something without a partner, right? Two things combining. I'm sorry, the partners are really more for replacements. Okay, two things combining. So let's use blue here. Can you see sulfur here is by itself and oxygen is by itself, right? And they combine to make sulfur dioxide, right? So here are a couple examples of that. Magnesium plus oxygen gives magnesium oxide, right? Sodium plus chlorine gives sodium chloride, right? And sulfur trioxide plus water gives sulfuric acid. And you can see in all three of those cases, you have two things that come together and combine, okay? So some photos of from your textbook of combination reactions look like this. You've got magnesium metal, and if it gets hit with oxygen from the air, this is burning, right? We've got this little ribbon of magnesium metal, and it's burning in air. It's going to make magnesium oxide. Okay, decomposition reactions, as I said before, when you have two things that fall apart. So we might have, excuse me, mercury 2 oxide, that is mercury 2 oxide because the oxidation state is 2. Mercury 2 oxide falls apart to liquid mercury and oxygen gas. And we might have the same thing with potassium chlorate. It falls apart to KCl, which is a salt, and oxygen gas. Right? That's a decomposition reaction. Things falling apart. A picture of that might be this, where you've got some solid mercury 2 oxide, right? And then if you add heat to it, if you heat this up, then liquid mercury comes out. There's the solid at the bottom. Liquid mercury comes out, and oxygen gas is released. Okay. Single replacement now is here's single replacement. Single replacement might be might be good to think about this as like people on a dance floor, right? So here you have one man dancing, or one man standing on the perimeter of the dance floor, and here's another man dancing with a woman, and this man says, "Hey, may I take this dance?" And he does, right? And he leaves this man over on the perimeter, crying in his tea. Okay, so here's your zinc. Here's your man standing on the edge. He says, "You know what? May I have this dance?" Zinc chloride forms, and H2 is left lonely at the end of the night. Same thing goes here with iron, right? Iron says, "May I have this dance?" Right? That's a single replacement reaction. Okay? I'm not going to show you the picture of that. It's in your textbook. Double replacement reaction is when this man says to this couple, I would prefer to dance with you. I guess that's not so, it's a little more difficult to imagine that. But that being the case, then this man says, I'll dance with you. Okay? You see how they see how they switch? So that is a double replacement reaction. And the final reaction that we're going to consider, I'm not going to show you the picture, that's in your textbook. The final one is combustion, where you have something, we're going to say carbon-containing compounds. A carbon-containing compound combines with oxygen gas to form water, okay? So methane combining with oxygen gas is going to form carbon dioxide and water. Propane combines with oxygen gas to form carbon dioxide and water. And that is a combustion reaction. So the summary, table 7.3 from your textbook, this is where I started out with you, right? I didn't give you this precise of a definition at the very outset, right? There's a carbon-containing compound, combines with water to make carbon dioxide, combines with oxygen gas from the air to form carbon dioxide and water. And it usually, always, I guess, releases energy, okay? So let's do a learning check now. Sorry for the background noise. Got a lot of people here. Sorry for the background noise. And let's do a learning check here. Identify each reaction as combination, decomposition, combustion, single replacement, or double replacement. All right, pause the video, look at those definitions, and come back and check your answers against mine. Okay, so I'm going to suppose you did pause it, and here's aluminum saying to that sulfate, hey, let's dance. So this looks like this is single replacement. Okay. Okay, let's look at this one now. Sodium says to nitrate, hey, I'd like to dance. And silver and sulfate go together, right? You see that? So this looks like this is double replacement. Now, in this case, I've got two things coming together to make one compound. This looks like a combination reaction. And here, it looks like it's a carbon-containing compound making carbon dioxide and water. So this is a combustion reaction, okay? Now, identify each. Let's do this again. Pause the video and come back and check your answers against mine. Okay, I'm going to suppose you pause it. Barium and nitrogen make this stuff. That's a combination. It looks like here I've got silver coming over to sulfide and saying, hey, let's dance. So this looks like this is a single replacement. What about this one? Here's a carbon-containing compound, going together with oxygen to make carbon dioxide and water. That's a combustion reaction. Okay? And this one looks like I've got lead sulfate, lead and sulfate, look at this, are being replaced or switching partners with potassium and chlorine. That looks like a double replacement. And then here I've got one compound breaking down into two. This looks like a decomposition. All right, hope that's helpful. You'll get more practice in your homework. Good luck.